When you think about DNA, you think about long hours reading in your bio book about replication, and worst of all, protein synthesis.
Shivers.
But there is one thing called epigenetics that goes way past those long hours of reading about translation.
The development and maintenance of an organism is orchestrated by a set of chemical reactions that switch parts of our genome off and on at strategic times and locations. Epigenetics is the study of these reactions and the factors that influence them.
So, your environment can affect your genes and how they're expressed. Certain things shut on and off genes to change what they code for in one lifetime.
So there are many things like acetylation and methylation that alter the expression of histones. And there's also things like operons, activators, and repressors that change how a gene is transcribed in the proteins made.
Certain things like malnourishment during the early stages of an embryo's development can affect the way their genes are expressed.
Wait, what? You don't know what you're talking about.
No, it's true. Prenatal exposure to famine causes negative health issues for the offspring later in life. However, what was even more intriguing was that the increased loss of needed epigenetic marks correlated with prenatal exposure to famine within those first 10 weeks of post-conception, and not for those exposed near the end of pregnancy.
Wait, so like those babies in Africa?
Yes, Emma.
So what your mother does during her pregnancy and what affects her affects your genes and how they're expressed in you.
Yes, exactly. If a mother expressed, say, a lot of stress during her pregnancy, that could result in abnormal gene expression for the baby, such as being born prematurely or undersized.
So the higher levels of cortisol caused by stress affects you and the baby's size and their development.
Yes, cortisol can also affect the mother's vascular system.
Social interactions can also affect your gene expression. Express yourself. Check yourself before you wreck yourself.
Yeah, okay, Laurel. But also, in addition to the stress, a mother's love can affect her baby.
Take rats, for example.
The nurturing behavior of a mother rat during the first week of life shapes her pup's epigenomes, and the epigenetic pattern that mom establishes tends to stay put, even after the pups become adults. The licking rat story tells us that there is another path to the offspring's DNA. Through her licking behavior, a mother rat can write information on her pup's DNA in a way that completely bypasses eggs and sperm.
Is the changing of our gene expression. Not only is our gene expression changed when we're itty-bitty fetuses inside our mother, but in social interactions in our lifetime.
I wonder if I would have turned out differently if my mom had come to my 6th grade band concert.
Okay, no sob stories, Chloe. We don't know if this affects humans in our lifetime, but we've seen studies in this in rats.
So can I pull a Coach C and say, that's job security?
That's exactly the point, Chloe. So now we know that DNA is not as simple as we think it is. Changes when you're developing in your mom and social interactions in your lifetime change your genes.
Exactly. It's not all bases in replication. We have to dig deeper to find out what composes the living world made up of cells and their functions due to our dear friend, epigenetics.